Good afternoon to everyone. Welcome to Bytes Expert Series. My name is Bhargav HK, Program Lead, Bytes Bengaluru. I would like to welcome all participants and today's expert, Dr. Apurba Das. Today's topic is computer vision, challenges and research opportunities. Today, we have an eminent expert, Dr. Apurba Das, Technology Head, Cognitive AI, Tata Consultancy Services, Bengaluru. He has 20 years of experience in computer science. He is industry advisor for implementation AI and computer vision solution to solve industry problems. He has 41 patents filed in USA, India, Europe, Japan in recent years. He has 40 published papers in reputed international conferences and journals. He is sole author of 5 books which are published from Spinger, Germany. Sir has PhD in computer vision and deep learning. He is a blogger at TCS website. Dr. Apurba Das sir, once again I welcome you for Bytes Expert Series. Now over to Dr. Apurba Das.
Hi, thank you for the introduction. I think you can see my slide, right?
Yeah, it is visible. Sir, you
Okay.
go ahead.
So our today's topic is computer vision challenges and opportunities. So before we go there, let us try to define what is computer vision very informally, and then we'll take it from there. So primarily, whenever we are talking about artificial intelligence is nothing but an attempt to create intelligent machines or intelligent system where we are trying to imitate our behavior, human behaviors. Now, in order to react to any situation, we have to first of all sense the environment, and we can sense the environment through our 5 senses, out of which definitely vision is most complex but most accurate sensor. Now, if we are imitating the vision system of human, you are not only donating the eyes to the computer but also donating the vision system to the computer. Then it is called as computer vision. So it is part of artificial intelligence where the sensing is done through vision system. So essentially cameras. So stop me anytime if you have any question, and I will also ask too many questions I see by doing some experiments. So I'll do some experiments, visual experiments along with you. So this will be the agenda, very crisp agenda. First of all, I'll introduce my own group, Cognitive AI, what we do, challenges in computer vision, machine learning in computer vision, then some research topics I'll discuss on perception domain, and finally computer vision in action. Most probably we will not have time to touch upon hybridization of image processing and DL, but that should be fine. Anytime, please feel free to stop me. I cannot see the chat window, so I will ask some questions. Please interact. If you are muted, then please answer that in the chat, and I will request the host to let me know what is there in the answers. So computer vision everywhere, it is currently adopted by all the industries. It can be retail and CPG, where they're doing customer tracking in a store, customer behavior analysis, shrinkage detection, theft detection in a retail store through computer vision, manufacturing, product quality inspection. In transportation and hospitality, we know autonomous vehicle, traffic analytics, life sciences and healthcare, lot of medical imaging applications, energy resources and utilities, tower monitoring, wildfire detections, cable inspections, smart cities, finally, traffic management, facial recognition of suspects, and so on. So looking at this huge gamut of applicability, TCS has invested, and you can see, according to this particular survey of Allied Market Research, it is telling 6.4 billion of US dollar was the realized revenue globally in 2021, and in 2027 it is expected to grow up to $22 billion. So it's a huge market going forward. This is my group in brief. It's around 54-60 member team. Uh, I own one IP. My team owns one IP called as CCS Image and Video Analytics Toolkit. IP means intellectual property, which is backed by 61 patents as of now. More than 61, I think, around 65 patents. We have two innovation labs, one in Bangalore, India, another one in Cincinnati, Ohio, USA. Uh, so I'm responsible for owning this particular IP, maintaining this IP, uh, and even the roadmap for this IP. Then business, growing the artificial intelligence business for Tata Consultancy Services, and finally delivery. So we are not only inventing new stuffs, we are not only filing patent, but also we are delivering our solutions to end customers. So the entire circle actually we are targeting. The right hand side have shown some of the awards which we have won during last 2 years. Please stop me anytime if you have any questions. So now we'll see the challenges in computer vision. As I mentioned, computer vision means we are trying to sense the environment artificially through camera and then trying to react to the environment. So for an example, if there is any autonomous car, the vehicle can sense the person in front of the car and can react. React means it can press the brake or use the steering wheel to get rid of the accident. So this entire stuff is done through computer vision, from sensing to reaction and actuation. Now, what are the challenges? I have actually mentioned 6 different challenges here. These are the major challenges. Number one, choosing the right video analytics architecture. So previously people felt that theoretically we can get infinite kind of compute power at the cloud. So why not? We can go ahead with the cloud. But now, due to latency issue, due to the cost at the cloud, people are again going back to the edge. Change in environment, uh, as we know, cameras will get blind if it is adverse environmental effect. For an example, if it is raining, if it is snowy, or glare is sunny, reflective sunny, this kind of situation, cameras will be blind. So that time definitely computer vision may not work as expected. So we need to add lot of new algorithms to improve the vision of the AI. Availability of training data in all variation. If you are from machine learning background, you know the data is a fuel in machine learning AI. In computer vision especially, as we are taking decision based on vision, we should ideally have uh, the the amount of data which is representing different visibility, different view angle, different environmental condition, different size, shape, color, all possible variations needs to be incorporated. That is again theoretically next to impossible. Real-time processing and target accuracy requirements. So I'll address both of them together. Uh, for an example, again, let us take the example of autonomous vehicle. You are trying to drive a car without driver and there is one person in front of you. If the accuracy of the system is 99.9%, what does it mean? Can anyone answer? What is the meaning of 99.9% accuracy of person detection? So there is a camera in the car. The camera can see there is a person in front of the car, and then accordingly the car should take decision. Means it will press a brake automatically so that we can get rid of the accident. Now, what does it mean? So if the accuracy is 99.9%, definitely it is not a bad accuracy. But what is the meaning of that? What does it signify? Anybody?
Other person will die.
Yes. So out of 1,000 people, one person will die, right? One will be false detection. You are right. So 99.9% also is not acceptable accuracy. Ideally, we are expecting 100% accuracy. Now, if we are trying to improve the accuracy, we will end up adding a lot of complicated uh, compute blocks, right? So computational efficiency will be compromised. So we'll be adding a lot of complicated algorithms. And if you are adding a lot of complicated algorithms, then what will happen? It will hit the performance. It will be slow. Now, if the algorithm is slow, and let's assume the people detection accuracy is 100% now, and the algorithm is slow, which means Previously, it was giving me decision within 10 milliseconds. Now it is taking decision and it is giving me the decision after 50 milliseconds. What does it mean if it is taking more time? Not 50 milliseconds, even more than that, maybe 500 or 600 milliseconds. Previously, it was taking only 20 milliseconds. What does it mean? What will it signify now? So now I am able to accurately detect the person because it is 100% accurate. But as I have added a lot of complicated algorithmic block, it became slow. So what does it mean? What will happen now?
Now his hands and legs will break.
Yeah, or you might kill that guy. Although you know that's a person, but it is slow. So when you know that there was a person, that person is no more. Because it is slow. Your brain comes to know that later. So you can understand there is a trade-off between the time of processing and the target accuracy, and both for both the requirement is pretty high. That is another big challenge in computer vision. And finally, the last one is data security and privacy. As it is camera, it is capturing the entire scene. If you want to capture only one vehicle, it will not only capture that vehicle, right? It will capture the entire scene, whatever is visible to the camera. Now, in that purview, if there is someone uh, available in the scene, that person's face also will be captured. And that's where privacy comes into the picture. GDPR is General Data Protection Regulation. So it's one European standard. So the standard says you are not authorized to capture human ID or human identifiable information. So these all are really big challenges in computer vision. Now let us try to dig in and try to understand the two major areas of computer vision. One is image analytics, another one is video analytics. What can you see here? There is something in this picture. What is it?
A dog.
Yes, excellent. So it's a dog. One human can see. If you all cannot see, I will just show you. This is the ear, this is the head portion of it. These are the two legs. These are the two rear legs. And this is probably a tree. Now, it is not very easy for human even to understand it's a dog. And you can appreciate when computer sees only this, only zeros and ones. In this case, zeros are representing the black pixels and ones represent the white pixels. Now you can understand that it is really, really challenging for a computer to understand it's a dog. So from one particular image, if we have to infer something, then that is image analytics. And that's how the pixels are arranged. I think you have this basic idea. Any image is constructed through, digital image is constructed through multiple homogeneous blocks. So they are called as picture elements or pixels. And each picture element will have red, green, and blue intensities. So we can do face recognition. We can understand who is that person if we know this person through image analytics, not a problem. But what if the problem is little different? Let's say this is a bus and I want to count how many people are boarding and how many people are deboarding the bus. So we have to count the people, we have to detect the people, and we have to track their direction as well. You have to understand how many people are deboarding and how many people are boarding. So you have to understand not only detecting people in one image, but also tracking them across frames. Again, another one, which is traffic analytics. You have to understand at what speed the vehicles are moving. So can this problem be solved through single image? Hello? Hello? Can you hear me?
Audible, sir.
I asked a question. Can these problems be solved through only single image?
Not possible. You need a video.
Correct. So then that is video analytics. Now, let us try to understand what is machine learning. So definitely we all know, for all of us, our mother was our first teacher. So how learning happens? say my mother is trying to teach me the first alphabet, how to pronounce this alphabet, and I am pronouncing that, but it is not accurate. So what will happen? The child will have its echoic memory. The echoic memory will tell there is an error. So between these two A's, these two pronunciations, there is an error. Then we'll go to the learning algorithm, which is there in the brain. And this learning algorithm will finally give a feedback to the tongue positioning system, which is actuated here. And then child will position his or her tongue in a relatively better way so that you can pronounce better A. Then after multiple iterations, it is expected that they will pronounce definitely much better A, which is closer to your mom's pronunciation of A. And there can be multiple termination condition. It can be number of iterations my mom pronounced this A, and we have gone through this error and minimized the error. It can be the error is less than some set value. My mom is happy after 100 iterations or 200 iterations. She is happy because the error is so less. She will no more pronounce the same A. She will go to the same next alphabet B. And third one, it is not at all improving, but it is saturating. In that case, we have to change the model. So that's how machine learning also happens. And I have shown one equivalent diagram for machine learning. So you can see there is one reference value and some sensor is sensing the output, finally giving the measured output. This measurement error is going through a controller, and then the system input is finally fed to the system, which is again getting the system output. So does it look familiar, this block diagram? Does the second block diagram look familiar?
This is sequential diagram. I mean, sequential systems with the feedback, kind of.
Yeah, so it is a closed loop control system. So which means machine learning is nothing but a closed loop control system. And what is the basic difference between traditional programming and machine learning? In computer science, we provide input data and we write a code, and then we process that data through that particular program to generate one output. Like if you have data 1 and 2 and the program says you need to do a summation, you will get 3. But in machine learning, it is very tough to write that particular program, because say you want to determine how a chair looks like. Chair can have 1,000 or 2,000 such variations. So how will you write code to determine what's a chair? If you're saying that chairs will have 4 legs, some chairs will have 3 legs as well. Some chairs will have a bench kind of system where only 2 legs will be there, and there will be no rear 2 legs. It will be fitted onto the wall. All are chairs. Now, how can you understand what is a chair? If this understanding is really complicated, we'll let the computer write the program. So we'll tell that I'm giving the data and I'm telling what is my expected output, and you write the program for me. So software writing software, you can see the difference between these two. We are just switching or swapping the position of program and output. Output is available for me. I know this will be a chair, and data is the image of a chair. So now I have 10,000 chair images, and I know all of them are chairs. So I'll tell the computer all of these are chairs, and these are the chair images. And you write a program through which I can understand what's a chair. Now you can give 1,000 fast chair, and that will be expected to be detected as a chair. In the language of machine learning, we call this output as label, and we call this program as model. Any question till now? Hello?
No, sir.
Okay. So now we just spoke about machine learning, but machine learning is definitely only a subset of intelligence. Intelligence is not equal to machine learning. Now people are calling ML and AI synonymously, but that's not true. So intelligence includes reasoning, learning, planning, knowledge acquisition, intelligence search and sort, and finally uncertainty management. So intelligence, definitely learning is only a subset of intelligence. So in entire AI, machine learning is a subset. And machine learning can be done through multiple ways. There are different algorithms like support vector machine, decision tree, random forest, and neural network based machine learning as well. If the neural network-based machine learning is employed and number of neurons or number of neural layers, hidden layers are more, number of tunable parameters are in billions, then we call that kind of machine learning as deep learning, because those neural networks are really deep neural networks. And as I mentioned, billions of parameters needs to be trained. So this learning is called as deep learning. I'll just take one example of face recognition. You all understand what is face recognition. You have your face in a large gallery. Say you have one gallery of 1 lakh images and your face is one of them. Face is deformable pattern. It deforms with respect to pose, illumination, expression, ornamentation. So if you are coming in front of the camera with different pose or illumination expression, the expectation is I should be able to understand who you are. Now I'll show you the history of this particular research, how it evolved. It's very interesting. Okay, before we go there, do you know who is this person?
No.
This is famous Hollywood actor Christian Bale. Uh, he hosted as the Batman. So leftmost and rightmost images are from Batman movies, and middle image is from the Machinist movie. Same person, but you can understand they look very different. So you can understand how difficult it is for the face recognition to say all three of them are same person. This is how it evolved. So primarily through machine learning, people used Gabor wavelets. They wanted to understand the features on the 14 fiducial points on the human face and tried to do dot product A transpose B to understand who is that person. Then it came to deep learning. In deep learning, again, it is software, writing software. So we are not telling the algorithm that you have to detect eyebrows, you have to detect nose, eye corner, nose bridge, and so on. No, we are just supplying images and telling this is this person, this is this person. And accordingly, it has actually created, we have got the FaceNet, which means it is trained through Facebook data. And then the deep learning knows what are the important features of face. Now it can have 1000 or 104 neural net hidden layers in the deep neural network. But if you want to train your face, it is very simple. You can do transfer learning. You can unfreeze last 2 layers and train them. It will take not even a second, and then your face recognition system is ready. Then it came to capsule network. So deep neural network or convolutional neural network could not give us the association mapping, which means if your eye is here, if one image is created which looks like this, it will still say it is you. And if your face is rotated, it will not be able to recognize it's you. Then capsule network came. It worked on this this coupling coefficient and association logic, and it could actually understand even if the face is rotated or the face is scrambled. It can actually understand what is face and what is a non-face. But finally, if I ask you a question after all three of them, is this how human does the face recognition? Is this how you will understand who is your friend, who is your mother, who is your father? If you want to recognize your teacher, will you try to fit some red dots on 14 fiducial points like eyebrow, eye corner, nose tip? No, right? You will not even do that unconsciously. So it is not correct. Correct way of doing it by human. So how human brain will work is completely different than all three. So that's where psychovisual perception is coming into the picture. So the first thing what human does is figure ground segregation, which means given one image, it will try to understand what is my figure of interest and what is my background. It's a binary segregation. Then our brain will ask what are the grid level textures available in the entire face. Again, it is not accumulated, but separately local level feature. Then third question it will ask, okay, including all the pixel intensities, texture and figure of segregation, what is this object? So there are three different layers. This is actually described very nicely in this book by David Moore. The name of the book is Vision. where he has proved vision is a combination of eye, processing the vision system in visual cortex, communication through different channels like dorsal and ventral, neurology, and interestingly, psychology. And even in this book, this famous book of Charles Darwin, Origin of Species, although he has shown how human eye evolved, but still uh, he has shown some kind of doubt, and he mentioned it seemed as the first glance absurd in the highest possible degree that it has been built through natural selection. So it's very interesting quote from his book. So that's why I was first of all writing it is human eye, but later I started off and called it as vision system. It is combination of eye, processing in visual cortex, communication through different channels, neurology and psychology. So in order to understand the vision system, how human vision system works, we have to attack in a different way. We have to study where exactly our vision system fails. Fails means generates different result with respect to computer. It is very important because it is very accurate. So it is inaccurate with respect to computer in only few cases, and then most probably we can try to bridge the gap. Are you seeing something funny in the left hand side image? Harman grid illusion, this image. What can you see there?
Nothing, sir. I can see only grids.
So you can see some grids, and can you see some red circles at the junctions and some black circles coming up and down? These lines are all of same intensity, vertical and horizontal. There is no white circle in between, but visually you can see there are some white circles and some black dots, which is an illusion. Similarly, grating index illusion, these are sinusoid image. So slowly it will become white and black and again white, again black. Whereas at the center patch, it is completely gray. So, but you are seeing something very different where it's a little dark and little bright near the patch. So these all are illusions. This is done through our vision system. Our primary visual cortex is realizing that, but computer will not realize that. Computer will say this entire thing is completely gray. Computer says this pixel intensity, this pixel intensity, all are same, but actually that is not the case. So to realize that, we try to understand how our retinal receptive field works in human brain, and then we try to model the retinal receptive field, the on center off surround and off center on surround retinal receptive field through two different Gaussians. We call it as difference of Gaussian, and then try to apply this difference of Gaussian curve onto the original image, this one, and then we realize whatever we could see, what computer could not see. From there it started. Then we have developed uh, another algorithm called as NFGS, Neurovisually Inspired Figure Ground Segregation algorithm, where we have incorporated glial cells and created another two-dimensional filter to do the figure ground segregation. So here you can see we are doing phase detection from binary images, and we have actually compared our algorithm with all the other binary images as well, a binarization algorithm as well. And you can see from original image how Bayes algorithm works, how Watsu's algorithm works. Then you can see different outputs from the original image, and ours has given the best result. We tried to use NFGS even for low quality face matching. You can see here you have some contrast issue, non-uniform contrast. Here you have resolution issue. Here it is contrast issue again. Here you have on shadow, no shadow, and here it is motion blurry. For all those cases, we could create this as output, whereas the state of art binarization algorithm could create this output. And you can appreciate that we cannot do face recognition with this low quality output. We have done face recognition with binary images, and this is already on published paper, and you have got really excellent result even with low quality faces. This is another research you have done for generating raw primal sketch from from just interaction with computer. So computer is expected to draw a sketch of a suspect where you are just describing the subject to the computer, and the computer will come up with the sketch. So that's how it works, and it could come out with a really good result. Any question?
No, sir, no.
Any comments? You have to add anything? You have to say something?
Nothing, sir.
Now you can please stop the recording and confirm, then I can move to the next section.
It was very interesting.
Thank you.
Any queries from participant side?
So how do you distinguish whether he is scanning and he is not having valid? How do you behavioral aspects, actions, how do you distinguish?
So we are trying to track his activities. So we are trying to understand what is the gesture, where the hands are, whether the hands are occupied with items or not. And then we are trying to understand the sequence of activities. Like now he is picking some item from the basket zone. Now he is scanning because he's spending some time at the scanning zone with occupied object. And then he's putting the item on the bag. And it is also integrated with the point of sales. Okay.
But how do you distinguish? Is a fake card is not valid, or amount is not debited, credited.
Correct. So for the final payment stuff, it is not only gesture based, it is gesture plus point of sales. So point of sales means at the payment terminal, we'll get on authorization. So after the payment is successful, we get on authorization. So it's a flag to AI algorithm which will tell the payment did go through or payment did not go through. So that is not AI, that is straightforward point of sales integration.
It's very interesting. Good.
Any other question?
Then you said if you tell a story, it will build a face. Can you talk on that something?
Pardon?
If you tell the face, describe the face of the person, it will build the face, a 3D model of the face. Can you talk about something about it, how it works?
That was not 3D model. The raw primer sketch, that is actually creating a sketch of your person. So you have seen, right, in a crime scene,
Yeah.
If some evidence is there, so that person will go, the witness will go to the police station and he will describe the person.
Yeah.
And there will be some specialized artist who will sketch it.
Yeah. But how it computer vision will do it?
Yeah. So for that, you should read that paper. I'll project my screen again, because I think we will not have time to go through each of the things in detail. I'll just share the links. Hold on. I'm sharing the screen again. You can just note down the details of this paper.
Or you can put it in the chat box if possible, link.
Even on Monday also.
You can note down. Can you see this? It's published in 2017. The name is Engineering the Perception of Recognition Through Interactive Raw Primer Sketch by HNFGS and CNNMRF. It has got the best paper award for this conference as well.
Is it open source or?
I think it is available in Springer. So if you have Springer subscription, then you can get that.
I see. Okay, sir. Okay.
It is not freely available.
Yeah, that's what it is. Okay. Okay.
So there will be some layers, eyebrow layer, layer 2. So if you're saying this is eyebrow, if you click eyebrow, then different layers will come flat. What is the length, width, curvature, and so on. Similarly, for eye, you will have again another hierarchy. And if you are telling this to computer will try to understand this hierarchy. It will minimize the mutual information. There's a concept called as mutual entropy. So it will try to maximize the information and minimize the number of questions. The computer will ask you one question, you will answer, and based on this answer, it will formulate new question. So that finally it can arrive onto the final one image, and then it will show the final image. It will not show iterative images, and with the final correction, you will get the real output.
Yeah, thank you, sir. It's good.
Yeah. Any more questions?
No, sir.
Okay, thank you. If there is
Thank
no
you.
more questions, we'll stop it. Thank you.
Thank you everyone. On behalf of all the participants and Bytes team, I would like to thank Dr. Apurba Das sir for such a informative session. Thank you, Dr. Apurba Das sir. Thank you, sir.
Thank you.
I thank all the participants for joining Bytes Expert Series. Kindly do attend Bytes Expert Series on every week from 3 p.m. to 4 p.m. Thank you one and all.